Sampai ఏం వాయిస్ ఎక్కడ స్ట్రీమ్ పెట్టేసాను కదా ఇది ఏంటి పడుతుంది
Science, so good afternoon, everyone. So I think the last session we have discussed something about data structures. Okay. All the data structures are categorized into two types. So linear and nonlinear. Again, the linear there are static and dynamic. So static data structure is nothing but dynamic, and dynamic data structures are static. I think as of now we have done the linear system and static. So now we are going to discuss about liquid list. So sorry, we are going to discuss about fuse concept. So before we start fuse, so we should remind this stack. So what is a stack? What is a stack? Silence. What is a stack? Stack is a linear dynamic data structure. Stack is what? Linear dynamic stack. Linear dynamic data structure. So there are two mainly operations we can perform using the stack. One is push operation, one is pop operation. So push is nothing but insertion and pop is nothing but deletion. So we can perform the push operation as well as pop operation from one end only. From one end only. So meaning is ఒకటే end నుంచి మనము push గాని pop గాని చేస్తాము. So దాన్ని మనం ఏమంటామంటే top of the stack. ఏమంటాము top of the stack. So we will insert the element into the stack using top of the stack, and we will delete the element. We will delete the element from the stack by using top of the stack. Okay. So stack follows LIFO order. Stack follows what? LIFO order. Last in first. Last in first. So whatever the elements enter into the stack with last. So whatever the elements enter into the stack lastly, so that element will be deleted first. Okay, why? Because stack follows LIFO order. Last in first. So there are majorly two. Push operation and pop operation. Okay, and only one end. That is top of the stack. So by using stack we can perform. So multiple application. So we can implement it multiple application. Okay. So majorly we can perform the push operation, that is insertion, and pop operation, that is nothing but so pop operation, that is nothing but deletion. So stack follows LIFO lasting first term, and we can implement it in so many ways, like infix and postfix expression, evaluation, and we can implement it in redo and undo features. We can implement it in redo and undo. So operation in the editors. Okay, so while developing the code, some amount of time, so we will redo and undo concept. So కొన్నిసార్లు మనం modification చేయడానికి ఆ editors లో Photoshop లో యూజ్ చేస్తాము, and forward and backward features in the web browsers. Forward and backward. Okay, so this is the main features. These are the applications, and usually many algorithms like tower of Hanoi and tree traversal as well as sugar problems. So next, and other applications can be backtracking and helping problems. So we will cover this topic in the advanced data structures in the coming semesters. Okay, so as of now, just observe that the stack is a linear dynamic data structure which is used to delete and insert the element from the top of this stack, and stack can be used in many applications. Stack can be used in many applications. And so this is about stack. From from the top of the stack only we will delete. And stack contains two states: overflow and underflow. So what is the meaning of overflow? If the stack is full, all the elements are inserted, so that is called as stack overflow. If stack is empty, that is called as stack underflow. Stack overflow and stack underflow. So using the array and using something express evaluation and something, so we will include that. And coming to the point Q. And coming to the point Q. So like stack, Q is also a linear dynamic data structure. Q is also a linear dynamic data structure. Then what is the big difference between stack and Q? Stack follows before order, whether it is nothing but so last in, first out. But Q follows before order. Q follows what? Before order. What is the meaning of before order? So first in, first out. First in, first out. So Q is also a linear data structure. Linear data structure. Q follows before order. First in, first out. So whatever the element inserted into the queue, that element will be deleted first. So ఏవైతే first insert చేయబడతాయో ఆ first insert చేయబడిన element మాత్రమే first delete. Okay, stack follows before and queues follows before. And stack లో మనం ఎన్ని ends తీసుకున్నాము? Only one end, that is top of the stack. That is top of the stack. But when coming to the queue, queue contains two ends. Queue contains two ends. That is nothing but the queue contains two ends. One end is called as array and other end is called as front. So queue contains two ends. One is called as array and another called as front. From the front, we will delete the element. From the rear, we will insert the element. From the rear, we will insert the element. From the front, we will delete the element. So Q also perform two operations. So do not write. I will give the notes separately. So not a problem. I will give the notes along with the program. So that program can be executed by in your mobiles. Okay, online editor. So not a problem, but understand the concept. Okay, what is Q? Q is a linear data structure. Q follows what? Before, first in, first out. Q contains how many ends? Two ends. One is rear end, another one is front end. From rear end, we will insert the element. From rear end, we are inserting the element. From the front end, we will delete the element. Okay, so in Q, so one end is always used to insert the data. In Q, one end, there are two ends. One end is always used to insert the data. So in Q, one end is used to always insert the data. That end is called as NQ. That end is called as NQ. And other end is always used to delete the data. Other end is always used to delete the data. That is called as DQ. There are two concepts, NQ and DQ. So one end is used to insert the data. That end is called as NQ. And other end is called as delete the data. That is called as DQ. So from which end we are going to insert the element? rare head, inserting the element. Insert ఎక్కడ నుంచి చేస్తాము? Rare head. That is also called as NQ. That is also called as NQ. And from which end we are going to delete the elements? Front end. That is also called as NQ. So when you observe the diagram, so this is rare and this is front. And from the where we are going to insert the element. So this is where we are inserting the element. So we will insert 25 first, then 50 next, then 5 next, and 30, 20, and followed by 10. So whatever the value is inserted first, 25 is inserted. So first element will be deleted. Okay, so this is what first in, first term. First in, first term. So this is what Q. So tell me, what is the Q? The Q is a linear data structure which is used to perform two operations: insertion and deletion. In Q there are two ends, rear end and front end. So rear end is used to insert the element and front end is used to delete the element. So Q follows before order first in, first out. So whatever the values are inserted first, that elements will be first deleted. And Q, one end is called as MQ and another end is called as DQ. And Q contains set of elements and rear and front. Rear and front. So for example, so in a real world, so let us assume there is a one way, so into that one way, so multiple vehicles enter into that road. So whatever the vehicles are enter into the one way, that vehicles will be exit from the same scenario. So first in, first out. So this is the real time example. And from where we use this queues concept, like stand. So queue also can be used in so many applications. I'll give the names. Okay, so queue also can be used in so many applications. So majorly, so queues are used to develop a waiting list mechanism for a single source applications like printer, disk, and CPU. Why? Because printer లో మనం ఏం చేస్తాము, continuous గా papers అనేవి print ఇస్తూనే ఉంటాము. So whatever the papers are given for the printing, that will be waited in the queue. So that the printer will take the papers from one by one and it will do the print. So like this also same thing, and CPU, some of the waiting mechanism will be implemented in CPU using queues. And asynchronous data transfer, like file input and output and so and third one, so buffer also same like waiting system. Waiting system that can be implemented in media players. And finally, so add the songs and remove the songs from the media players. We can add the song and we can delete the song from the media player. So this is also can be implemented using queues. And the queues are used to handle the interrupts in the operating system. Queues are also used to handle the interrupts in the operating system. Okay, so queue is a data structure which can be implemented in many applications. Like waiting list mechanism in the printer and this kind CPUs. And some of the applications like so asynchronous data transfer in the file size, file input output operation, as well as in the circuit programming. And the queue also can be implemented as a buffers. In a media players. And in the same media players, you can add the song and we can remove this. And the queues are also important the queues are also important while handling the interrupts in the operating system. So interrupts are nothing but errors. Interrupts are nothing but errors. So that errors can be handled by the queues. That are also by the handled by the queues. Okay. So there are types of queue. There are types of queue. So simple queue, circular queue, priority queue, and double-ended queue. And double-ended queue. So very important. How many types? Four types. What are they? Simple, circular, priority, and so simple queue is like normal queue. Simple queue is like normal queue. There are two ends, rear end and front end. From rear end we will insert. From front end we will delete. So not much better. So not much difference is there. So it is a simple queue. From rear end we will insert the element. From front end we will delete the element. Okay. So no change between so normal queue and simple queue. And coming to the circular queue, in a circular queue, all the elements are treated as known. All the elements like treated as known. Each node form a circle. Each node form a circle. Each node form a circle. How it is formed? The last node will be connected with the first node. The last node will be connected to the first node so that it forms the circle. So that it forms the circle. So there is a connection between so last node and front node. Last node and front node. So we can represent this into this circle. We can represent this into this circle. So this is called as, this is also called as ring buffer. This is also called as ring buffer. So same thing. Same thing. So we can delete the element and we can add the element. We can delete the element and we can add the element. So we can insert from the rear and we can delete from the front. But only change is the rear node is connected with the front node so that it forms this circle. So that it forms the circle. So if it is formed the circle, this is called as ring buffer. It is called as ring buffer. And priority queue. And priority queue. So priority queue is also one of the queue. Priority queue is also one of the queue. So all the nodes are available. All the nodes are available along with the priorities. Along with the priorities. There is no change in the insertion. There is no change in the insertion, but change in the deletion. While deleting the elements from the priority queue, so it always delete the element which has the highest priority. It has the highest priority. So in a priority queue, the data items which have the some present priority, while removing an element from the priority queue, the data item with the highest priority is removed first. Okay, the insertion is no change. The insertion is performed in the order of arrival. The order of arrival. So whatever the values are, arrival for the insertion, that values will be inserted along with some priorities. But when I want to delete the element, so it will delete the highest priority first. It will delete the highest priority first. So let us assume, so this is data and this is priority. So this is a data 1, 5, 6, 11, 13. So if I enter 13 and if I enter 11, if I enter 6, if I enter 5 and if I enter 1, there is no change. From the rear end we will insert the element. From the rear end we will insert the element and along with some priorities are 1, 2 and 3. So these are the priorities. The black color is called as priority. So if I want to delete the element from this priority queue, so it will delete first highest priority. The highest priority within this example is 3. Highest priorities within this example is 3. So it will delete this element first. And next, double-ended queue. Next is what? double-ended cube. So in the double-ended cube, so normally general cube contain two ends. One is rear and another one is front. But when it comes to the double end, so we can perform both the operations, insertion and deletion. So generally we can perform the insertion from the rear end and the deletion from the front end. When it comes to the double-ended cube, both the operations, insertion and deletion, we can perform from the both the ends, from rear end and from the front end. From rear end we can perform the insertion as well as deletion. From the front end also we can perform the insertion and deletion. So there are categories in the double-ended cube. There are categories in the double-ended cube. Input restricted and output restricted. Input restricted and output restricted. So DQలో main feature ఏంటి? DQలో main feature ఏంటి అంటే so we can perform both the operation from the both the side. We can perform both operation like insertion and deletion from the both the side. ఒకవేళ ఇన్పుట్ రిస్ట్రిక్టెడ్ అంటే మీనింగ్ ఏంటి అంటే ఓన్లీ వన్ ఎండ్ నుంచి మాత్రమే ఇన్స్ట్రక్షన్స్ పనిచేస్తుంది. ఓన్లీ వన్ ఎండ్ నుంచి మాత్రమే ఇన్స్ట్రక్షన్ పనిచేస్తుంది. ఫ్రమ్ బోత్ ద ఎండ్స్ మాత్రం డిలీట్ పనిచేస్తుంది. అండ్ అవుట్పుట్ రిస్ట్రిక్టెడ్ అంటే మీనింగ్ ఏంటి? అవుట్పుట్ రిస్ట్రిక్టెడ్ అంటే మీనింగ్ ఏంటి? ఓన్లీ వన్ ఎండ్ నుంచి డిలీట్ పనిచేస్తుంది. ఫ్రమ్ ద బోత్ ఎండ్స్ ఇన్స్ట్రక్షన్ అనేది so work అవుతా ఉంటుంది. So you can observe this diagram. So this is input restricted double-ended cube. This is input restricted double-ended cube. So insertion operation only from the front. There is no insertion operation from the rear. But when it comes to the delete, you can delete from the front and you can delete from the rear. So this is called as input restricted. Then what about output restricted? So you can delete the element from only rear end, but you can insert the element from the both end. This is called as output restricted double-ended cube. So ఇప్పుడు చెప్పండి, what is Q అంటే ఏం చెప్తారు? Q is a linear data structure which has how many ends? Two ends. What are they? Rear end and front end. So insertion operation will be performed from the rear end. Deletion operation is performed from the front end. So Q's follows what? Tipo order. First in, first out. So one end is always used to insert the operation. One end is always used to insert the element that is called as LQ. One operation is always used to delete the element is called as delete. Okay, and there are four types of queues. What are they? Simple queue, circular queue, priority queue, and double-ended queue. Simple, circular, priority, and double-ended queue. In double-ended queue also there are two: input restricted as well as output restricted. And there are some application which uses queue or not. There are some application which uses queue. Waiting list in the CPU and disk and printers and asynchronous data transfer in the file input output operation circuit programming and waiting buffers in the media players, and we can add the sum and we can remove the sum as well as we can handle the interrupts in the operating system. So take the notes now. Q.
peanut butter on the bottom. Market is mixing peanut butter and peanut butter. Mixing I will cost that means chopping
we will insert the element into the queue. From the we will insert the element into queue.
అడిగావా కొట్టారా
From the rearrange, we will insert the element into the cube.
అయితే తెచ్చేసారు తర్వాత అమ్మ అన్నారు సరే మ్యామ్
And
అన్నాను మళ్ళీ ఎత్తింది
from the front end, and from the front end, from the front end, we will delete the element from the cube. We will delete the element from the cube. We will delete the element from the cube.
by 4 hour pancake.
Next, cube follows. Next line, cube follows. Next line, cube follows FIFO principle. FIFO principle. First thing, first term.
Kita tuh WhatsApp-nya kita sih by date dari aku masukin kan balik
Cube follows FIFO principle. First thing, first term.
nah saya ada bosku dong ya
First thing, first term.
ada perpanjang
Cube follows FIFO principle. First thing, first term.
super gede తీసుకున్నారు
First thing, first term. Next one. Next. In cube, in cube, one end is always used to insert the data.
potato
In cube, one end in cube, one end is always used to insert the data. In cube, one end is always used to insert the data. Is called n cube. Is called n cube. In cube, one end is always used to insert the data. Is called as n cube. And other end is always used to delete the data. And other end is always used to delete the data. Other end is always used to delete the data. Is called DQ. Is called DQ. NQ and DQ. So take the picture. NQ, DQ, some element rear and front. So take the diagram. Take the diagram. Next, applications of Q. Applications of Q. Applications of Q. Applications of Q. Qs are usually Qs are usually Qs are usually weightless mechanism. Qs are usually weightless mechanism. Weighting Qs are usually weightless mechanism of single resource reduced mechanism of single resource systems, single resource system,
Big pet.
single resource system, like printers, like printers, commodities, commodities, and city, commodities, comma, print, comma, this and city, this and city. I will verify the notes, each and everybody. So, చాలా మంది రాయట్లేదు. సో నోట్స్ రాయకపోతే చెక్ చేస్తాను. సో మీరే చెప్పాలి మళ్ళీ. ప్రోగ్రామ్ రాసిన తర్వాతనే బయటకు వెళ్ళాల్సి ఉంటుంది. ప్రోగ్రామ్ ఎగ్జిక్యూషన్ చేయించినప్పుడు మాత్రమే బయటకు వెళ్ళాలి. ఓకే, సో మొబైల్ లో ఆన్లైన్ ఎడిటర్ లో ప్రోగ్రామ్ ఎగ్జిక్యూట్ చేయాలి. ఎవరైతే నోట్స్ రాయట్లేదో వాళ్ళని మాత్రమే కాన్సన్ట్రేషన్ చేస్తుంది. ఓకే, సో అందరినీ అబ్జర్వ్ చేస్తున్నాము. సో ఎవరైతే నోట్స్ రాయట్లేదో వాళ్ళని మాత్రమే ఎగ్జిక్యూషన్ చేయిస్తున్నాం. ఇదే చెప్తున్నాను. ఓకే, సో మీరు చూసుకోండి. లాస్ట్ లో ఎవరైతే నోట్స్ రాయారో వాళ్ళు మాత్రమే ఎగ్జిక్యూషన్ చేస్తారు. ఓకే, సో ఎక్కడ చేస్తారు వాళ్ళు? స్టేజ్ పైన చేయాలి. మిగతా వాళ్ళందరూ మొబైల్ ఫోన్స్ లో చేయాలి. సో వెరిఫై చేసిన తర్వాతనే బయటకు పంపిస్తుంది. ఓకే, నెక్స్ట్ పాయింట్. నెక్స్ట్ పాయింట్, నోట్స్ ఉండాలి, అవుట్పుట్ రావాలి. ఓకే, నోట్స్ ఉండాలి, అవుట్పుట్ రావాలి. అప్పుడు మాత్రమే బయటకు వెళ్ళాలి. 4:30 అయినా 5 o'clock అయినా క్లాస్ లోనే ఉంది. సో నేనైతే ఎక్కడికి మీరు. ఓకే, సో యూ మిస్ ది బస్ ఆర్ సంథింగ్, ఐ డోంట్ నో. ఓకే, రైట్. సో నెక్స్ట్ పాయింట్, cues are usually asynchronous data transformation. Asynchronous data transformation. Cues are usually asynchronous data transformation. Asynchronous data transformation. Cues are usually asynchronous data transformation. Asynchronous data transformation. Example, pipes. Example, pipes. Example, pipes. File input and output. File input and output. File input and output and circuit program. Pipes, file input, output and circuits. File input, output and circuits. Next. Queues are used as a buffers. Queues are used as a buffers. Queues are used as buffers in most of the media players. In most of the media players, queues are placed. Add this one and delete this one from the place. Next, queues are used to Queues are used to handle the interrupts. Queues are used to handle the interrupts in the operating system. Queues are used to handle the interrupts in the operating system. Handles the interrupts in the operating system. Handles in the operating system. Next, types of queue. Ready? Types of queue. Handle the interrupts in the operating system. Types of queue. Simple queue, circular queue, priority queue, and double-ended queue. simple queue, circular queue, priority queue, and double-ended queue.
The cash check is something that you have to.
Okay, so now if you take the separate notes for simple queue, so it is the definition and the simple queue are same. Definition, simple queue are same. So it contains two ends, rear and front. From the rear we will insert and from the front we will take no change. And circular queue. Take the heading, circular queue.
Your batch
Buffer. Buffer. Circular queue is also called as ring buffer. Circular queue is also called as ring buffer. Circular queue is also called as ring buffer. So take this one only. Take this one only. So no need of this. Okay? Only this. Only one is enough. Only one is enough. So just write one statement. There is no change in insertion and deletion. There is no change in insertion and deletion. There is no change in insertion and deletion. That means, that means, we will insert the element from the array. We will insert the elements from the array and we will delete the elements from the front end. There is no change in the insertion and delete. That is, we will insert the element from the array and we will delete the element from the front end. We will delete the element from the front end. Next study, priority queue. Next study, priority queue. Study priority queue. In a priority queue, all the elements contains. In a priority queue, all the element contains. In a priority queue, all the element contains priority. All the elements contain priority. In a priority queue, all the elements contains priority. There is no change. There is no change in the insertion. There is no change in the insertion. There is no change in the insertion. But when we want to delete, when we want to delete, when we want to delete, when we want to delete element from the priority, when we want to delete element from the priority queue, when we want to delete element from the priority queue, the highest priority element will be deleted first. The highest priority element will be deleted first. The highest priority element will be deleted first. So take this diagram. Take this diagram. Okay. So blue color elements are data and brown color elements are priority. So mark them accordingly. Okay. In your notes, mark them accordingly. Some elements are blue color and priorities are black color. You should mark your notes. Identify our different kinds of them using. Okay, the second one are the priorities. First are element and second are priorities. Double-ended queue is a queue. Double-ended queue is a queue which allows which allows insertion and delete operations. Insertion delete operation from the insertion and delete operation.
Oh, yes, that's fun. పెట్టుకున్నాడు వచ్చిన చోటు ఇవన్నీ మాకు ఎన్నెందుకు మల్టీప్లై నాకు పెట్టుకున్నాడు నీకు నాకు పెట్టుకోవడానికి లేదని అడుగుతున్నాను పెన్సిల్ మల్టీప్లై ఓపెన్ చేసా ప్రైవేట్ జాయిన్ క్రియేట్ చేస్తున్నా నువ్వు జాయిన్ అవ్వు అది అదే ప్రైవేట్
సో ఇన్సర్షన్ ఎక్కడ నుంచి చేస్తాము delete ఎక్కడ నుంచి చేస్తాము and use ఏం చేస్తాము ఫస్ట్ సో ఏ ఎలిమెంట్ ఫస్ట్ ఇన్సర్ట్ అవుతాయో ఆ ఎలిమెంట్ ఫస్ట్ delete ఓకే నెక్స్ట్ సో queues అనే దాంట్లో 2 ends ఉన్నాయి కాబట్టి ఒక end is always used to insert the data, one end is always used to delete. సో insert చేసే end queue అంటాము